Hi, today we're going to discuss scientific notation. Scientific notation is useful when we're discussing really small numbers, such as the size of atoms and molecules, or really large numbers, such as the amount of atoms and molecules. Scientific notation is a form of writing very large or very small numbers that you've used probably before in science or in math. Scientific notation, it uses powers of 10 to shorten the writing of a number. When you're writing in scientific notation, the decimal point is put between the first non-zero number and the second number, and the power of 10 is the number of times it moved to get there. How many are powers of 10? A number that began large, greater than 1, has a positive exponent, and a number that began small, less than 1, has a negative exponent. Let's look at a couple examples. When you look at the first number, you can see that the decimal is between the 5 and the 2. So when we're writing in scientific notation, you want to move that decimal so that it is between the first non-zero number and then the one next to it. So that would be 1, 2, 3 spaces to the left. So we would write this as 1.20520 times 10 to the third grams. Okay, notice I'm still maintaining my significant figures in this number. For the second problem, we have the decimal, we want to move it over. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. And so we've got 5.88 times 10 to the negative 9 meters. And then for the last example, the decimal place, even though it's not there, we know it's over here at the end, over here. We move this over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we would have 4.501, watch your significant figures, times 10 to the 13th milligrams. Now let's look at reading scientific notation. A positive power of 10 means you need to make the number bigger, and a negative power of 10 means you need to make the number smaller. So you move the decimal place to make the number bigger, smaller, the number of times of the power of 10. Let's look at the example. So we want to write out the following numbers: 1.37 times 10 to the fourth. So we have 137, and we're moving it 4 to the right because it's a positive exponent. So 1, 2, 3, 4. So 13700, and I have the same number of significant figures. Now 10 to the negative 5, we're moving it to the left 5 spaces, 1, 2, 3, 4, 5, and so that would be 0.0006887. And then 10 to the negative 3, we move it 3. 1, 2, 3. That would be 0.007005. So if you just remember that the exponent, the power of 10, is the number of decimal places that you're moving it. If it's negative, we have smaller numbers, and if it's positive, we're discussing larger numbers. Now go on into your packet and do the quick practice problems.